This video is brought to you by Sporlan, quality, integrity, and tradition. Alright, this is a new customer, and we've got a reach and they're saying that's not working. I do not know all the symptoms because I wasn't given much information. All I know is that they turned it off. Okay, so I'm just going to turn it on and we're going to go through this thing. I know it was temping high, that's it. So check everything out. This looks like a glass tender knockoff, kind of. And I heard the click of death from the compressor. Yeah, this definitely looks like a glass tender knockoff. That's really interesting. I wonder if glass tender doesn't make their own reach-ins. Huh. Crown. New Jersey. This is like the same design of a glass tender. Huh. Alright, like I said, I heard the click of death. I hear the compressor going on and off on overload, so we're going to open that up and see. Okay, compressor's turning on and off. I can tell the capacitor's blown apart from here. We're going to get this guy out. It's like a couple screws. You can see fluid in there. I could see like the white stuff around the outside of the capacitor before I opened it, but yeah, the fluid capacitor's bad for sure, but we're going to test it, and I probably have a temporary one to put on there just to make sure the compressor starts up, so we'll see. Yeah, that's not good. It's like the dielectric fluid or whatever they put in there. Whatever type of oil. Yeah, it's interesting. 0 microfarads. That's not a shock. So this guy's dead in the water. Whether or not it's just a start capacitor or not, we'll find out. But again, I changed starting components as a set. But I'm going to see if I have a turbo start capacitor that'll get me going. Let's go see. AMRAD actually makes a universal start capacitor just like the Turbo 200 run cap. They make a Turbolytic 50, which is a universal motor start capacitor. This thing is awesome for the refrigeration guys. As you can see, I don't leave it at the customer side. I'll reuse it because essentially it's my hermetic compressor analyzer, because I can test continuity on the windings if that's good. I can test a relay by checking voltage, and I can throw a universal cap on there. And if I can get it running, then I'll order starting components. But these things are awesome, so let's see if I can get this thing running. See what happens. It's temporarily just sitting back there. Wouldn't leave it like that. Compressor started. We're going to let it run for a bit. Make sure that it brings the box down to temperature. And we'll make some phone calls and see if we can find the factory starting components. There still could be something else wrong with the unit, but we know we had a bad start cap, so we're going to let it run for a little while and then see where it gets us. This thing came down to temp super fast. I want to say 20 minutes, 25 minutes at the most. It's already at 33 degrees. So I'm going to go ahead and go pick up new starting components. They actually have them locally to me, so get those, and then we'll let it keep running with the temporary capacitor on there until I get back. These things can be a chore to get off, but okay, so you want to pay attention to the wiring, like the way it's running, because it all has to go back in the same place for everything to fit properly in here. But I've got all factory starting components, so we're going to pop these guys in and test everything after that. Well, if I didn't screw anything up, it'll be a miracle, because those things are so flippin' tight. I've got an amp clamp. I'm going to have to amp the entire condensing unit, so that'll tell me at least something. Let's turn it on and hope it don't blow up in my face. I'm assuming that means defrost, so let's turn that off. Okay, I hope I turned it off. Let's see if this guy turns on. .2 amps. It says run load for the compressor alone is 5.8, not including the condenser fan motor, so I think we're okay. I'm gonna let me check the refrigerant amount. I think I'm going to probe up with the field piece probes depending on the refrigerant charge on this unit. So I just shut the door Looks like it's in a time delay right now. We're going to watch this guy turn on. I probed up. It does take 134A. It's an expansion valve system. We're going to let it start up and then check. I'm pretty confident everything's good though. The only thing that concerns me was the compressor was running really hot on the head. But sometimes on these little guys they do that. We're not overamping. So let's just see what the refrigerant pressure should be. I haven't talked to the manufacturer, but I'm just going to go with about 25 degrees over condensing temp. Or you know, the condensing temp should be 25 degrees over ambient is my rule of thumb. Let's see if that's accurate on this guy. No more than 30 degrees. I don't think this is a super efficient system, although this one looks like it was manufactured in 2013 probably. So we will see. It should kick on here any minute as soon as the time delay clicks out. So we just kicked on. Let's see what happens with our refrigerant pressures. I am going to warn the customer too that whenever I change starting components and I can't find a reason, I always warn them that there's potential that there could be compressor damage. The condenser was a little bit dirty when I got here, but not plugged. But I always warn them about potential compressor damage. I'm not worried about measure quick's targets. The condensing temp over ambient is kind of accurate, but I'm not worried about the suction target. I'm more concerned about my evaporator temperature. See what my box temp is right now. So my evaporator TD is 17 degrees. I don't think that's horrendous. My condenser TD is right at 30. I think we're okay. I mean, 5.2 amps. I think we're going to give them the all clear and just tell them to keep an eye on it. I'm not seeing anything else that's telling me I should do anything. Let's go back, just out of curiosity. This unit has a receiver, so I'm curious. Yeah, see, I've got about 5 degrees subcooling. You know, checking subcooling with the receiver is always difficult. On the drain line coming out of the condenser, usually if I see at least 3 degrees subcooling, I'm usually a happy camper. This unit doesn't have a sight glass, so without calling the manufacturer, I'm not going to know what kind of refrigerant pressures they want, but I'm thinking we're probably somewhat okay. Alright, we're just about to satisfy, so. Alright, we're going to tell them to keep an eye on it.
All right, from the beginning, I showed that the start capacitor had failed, okay? I could see it right when I opened it up. Usually when you have these small hermetically sealed compressors, they do lose starting components a lot. What happens on them is they short cycle. Oftentimes, maybe the customer doesn't keep the condenser clean, or they're opening and closing the box a lot. Who knows? There's a lot of things that cause the starting components to fail. Sometimes it could be compressor damage too, in my opinion, okay? That's just things that I've noticed is usually, you know, sometimes if you have a high failure rate on starting components, typically you have issues with the compressor. But, you know, we personally have never changed these before, and they were factory components in there. So who knows, okay? But whenever I change starting components, I change all three as a set, preferably, okay? So the start capacitor, the current relay, and or potential relay, depending on the system. If it has a run cap, I change the run cap, and I change the thermal overload or the clicks-on relay, okay, or clicks-on, whatever you want to call it. Personally, the components themselves are extremely cheap, and if you're in there, it's just my opinion. I just change them all, okay? That's just the way that I do things. It's not like I'm ripping the customer off or anything. I'm doing them a service, and I always let them know, you know, we're going to change all three starting components because we change them as a set, that kind of stuff, okay? That's my personal preference. I'm not saying that you're a hack if you don't do that. For all I know, you guys probably think I'm a hack, but it is what it is, okay? That's just how we operate here. So we change all the starting components. Once I did that, everything was working okay. Now, I also tested the system using my universal start capacitor just to make sure that it would run. Now, as I was editing the video, of course, I look at them and I think, okay, you know, it probably would have been a good idea to throw an amp clamp on there when I was testing it just to see if we were having any funky issues. But regardless, we got it going and everything was fine, okay? I made the decision to go ahead and put my service gauges on there. I didn't, you know, I was kind of iffy whether or not I needed to do that. And to be honest with you, what pushed me over the edge was that this was a new customer. and I wasn't very familiar with them, and maybe the trust level that they have with me just wasn't quite there. Okay, so I felt the need to go ahead and put service gauges on there, even though the box was coming down to temp really fast. I just did. Okay, and once I did, you know, again, I didn't expect to see anything really strange. Okay, I made an assumption because I didn't talk to the manufacturer of what I thought the refrigerant pressure should be. Okay, there's no set in stone number here. Okay, and you can't go by 10 degrees subcooling, you know, 8 degrees superheat, whatever. You can't go by a set number every single time. Okay, you just can't. All right. It's an expansion valve system with the receiver. You're not going to run 10 degrees subcooling all the time. Okay. You know, the manufacturers, they do all kinds of weird things. For instance, okay, the suction line is ran with the liquid line in the same piece of insulation, and it's taped together. So before it goes through the insulation, the suction line is taped to the liquid line. So for those people, you know, especially on capillary tube systems that say, oh my gosh, you got to have this perfect superheat coming back or whatever, that number is not going to be as accurate as you think it is if it's wrapped in the same insulation, because it's acting as a subcooler essentially, right? And the suction line's absorbing the heat from the liquid line, making the box more efficient. Also on these boxes, oftentimes, they have a hot gas condensate loop. So the discharge line coming out of the compressor goes directly into the drain pan, and it creates a condensate loop for the condensation that comes off the evaporator to evaporate it. Now, if you have water in that pan, it's going to affect the system operation. Your refrigerant pressures are going to change, okay? Theoretically, you're dropping the discharge temp. Therefore, theoretically, you're going to drop the liquid line temp. You know, everything's going to change. So you can't just assume that everything's going to be this perfect number on these reach-ins. Now, of course, I always use my vitals as a guideline. You know, I'm always looking for some subcooling with the receiver, not necessarily 10. I'm always looking for, you know, mediocre superheat. I don't want extremely low superheat coming back to the compressor because that's an indication of flooding. But I don't have a set number in my head, okay? I just kind of use my senses. I walk up, I feel things. I feel the compressor, I check the current draw, I look at the refrigerant pressures, look at the evaporator pressure, look at the condensing temperature. Typically, I don't ever want to see anything over condensing temp that is 30 degrees over the ambient temperature, okay? Don't ever want to see that typically. So I make assumptions, what I call an educated guess with these things. Okay, I don't always call the manufacturer. This one, I wouldn't have gotten a hold of them because this was right at, actually, this is an older video, but this was right at the beginning of the COVID shutdown. So I wasn't going to get a hold of anybody. All right. Now, for the record, this box has been running fine for months now and never had a complaint from the customer. But regardless, always try to take a step back, you know, look at everything, especially on the new customers, okay? Because that trust level isn't quite there yet. And there's nothing worse than a callback, right? Callbacks happen, but there's nothing worse than them. You know, you want to try to eliminate that stuff. So I'm looking at everything. Okay. So I watched this box satisfy multiple times. I didn't see any other reason, anything to concern me. I did look at the receptacle behind the box. I did measure the voltage coming into the box. I know I didn't show it on the video. We had accurate voltage coming in. I didn't see any other issues. So I told the customer to keep an eye on it. And that's where we're at. Okay. I'm not a perfect tech. I make all kinds of mistakes. I'm always interested in your guys' feedback. Leave me some feedback down in the comments. Let me know what you think. How would you have done it differently? Would you have just simply thrown a sight glass on there? I have done that in the past, okay? If I ever had to open the system up, you know, sometimes I'll throw a sight glass on there. Who knows? But I'm always looking for your guys' feedback, good or bad. If you guys think I'm a hack, tell me. I'm not going to delete your comments. The only comments I ever delete from my YouTube channel is when you guys try to guess restaurant names. That's what I delete, okay? I won't tolerate right or wrong restaurant name guesses. That's the only ones I delete. And so long as you're not bashing other people or just being a plain punk or anything like that, okay? But you can tell me that I'm a hack. I don't care. That's all good, you know, because I'm always looking for feedback. If you have advice for me, give it to me. You know, I'm always looking to learn. I really, really appreciate you guys making it all the way to the end of the video. For those that do, thank you so very much. If you're interested, way to support the channel. If you guys are considering purchasing any tools, go to truetechtools.com. Use my offer code BIGPICTURE, one word. You'll save 8% on your order, and then I get a small commission. It helps to support the channel. You guys also can support the channel via my website, hvacrvideos.com. I have merch available, shirts, hats. I'm just about to get a big hat order in this week of all the large, extra large hats, so stay tuned for that, guys. Those of you that made it to the end, this is the announcement. The hat orders theoretically, well, not theoretically, tentatively, they're scheduled to be delivered Wednesday evening. So after I get them, I have to inspect them, make sure there's no damage. Then I'll put them up available on the website and they'll be for sale again. So stay tuned for that. And yeah, we will catch you guys Monday evening, 5 p.m. Pacific on the HVACR Videos YouTube channel for my Monday night live stream, work permitting, of course. And yeah, that's it. We will catch you guys on the next one, okay?